hopefully you've taken the opportunity to go ahead and complete this worksheet, the motion of a grocery cart. You can see here that we have this position as it's increasing, decreasing, flat, and then increasing, increasing again. So the instructions told us that we need to figure out what the initial position is, final position, the displacement, velocity, and direction. So keep in mind that we do note that the going away is positive and then going toward is negative. All right, so in each part, we figure out each position, the initial position and the final position. So you can see here we start at 4 and go up to 16, so that's the initial and the final. And then the final position, we go 16 to go to 4, and then we stay at 4 for this next time interval, and then from 4 up to 19, and then from 19 to 23. And you can see the time intervals there. We go 0 to 4 seconds, and then from 4 to 10 seconds, then 10 to 13 seconds, and then from 13 to 16 seconds, 16 to 20 seconds. All right, now to find the displacement, you take your final position minus the initial position. So once you figure out your initial and your final position, you simply subtract the two, final minus initial. It's always got to be final minus initial so that we can get our displacement and get the positive or the negative there. And then after that, we can figure out the velocity by taking that time interval, so the 4 seconds, so 12 divided by 4, that's what gives me 3 meters per second. And then because it's positive, it's moving away. The next one is negative 12 because it's 4 minus 16, so that gives me negative 12. And then we take that negative 12 and divide it by 6 because that's the time interval from 4 to 10 seconds, and we get negative 2 meters per second squared. And because it's negative, we know it's going toward, as indicated right here, that negative means toward. The next time interval from 10 to 13 seconds, it's the displacement is going to be 0 because it starts and ends at the same spot. That means the velocity is going to be 0, so there's no direction. From 13 to 16 seconds, we see that we go from 4 meters to 19 meters, so that's a final minus initial. It gives me 15 meters, positive. So 15 divided by 3 gives me 5, and we're moving away because it's going to be a positive velocity, 5 meters per second. And then for the last 4 seconds, we go from 19 to 23, so that's a displacement of 4 since it's 23 minus 19. And then that gives me 4 over 4, which gives me 1 meter per second. That's 4 meters divided by 4 seconds. You see from 16 to 20 seconds is 4 seconds. And then because it's positive, we're going to be moving away. The last part on this, on the front part, is going to be the average speed. Now, the thing I want to emphasize here is we're talking about speed. Now, speed is the total distance divided by time. Oftentimes we look at average velocity, which is displacement divided by time. Displacement includes the direction, but speed does not include the direction. So that means for the distance, you basically take your displacements and you make them all positive. So you can see this 12 is already positive, so we keep it positive. But this negative 12, we're going to make positive. And then the 0, we keep positive. The 15, we keep positive. And the 4, we keep positive. So that gives us 12 plus 0 plus 15 plus 4. And that gives us total of 43. And then we divide by the total time. So the total distance divided by the total time, that's 43 over 20. That gives us our speed, our average speed of 2.15 meters per second. Now, if you took the final position, which was 23, and subtracted the initial position, which was 4, and you got a displacement of 19, then took that 19 divided by 20, you would get something like 0.94 meters per second. But because that includes the direction, this being negative, it takes away, distance does not include that direction, so that positive right there is what changes the answer between distance and displacement. And that gives us our speed of 2.15 meters per second. And looking at the back of this worksheet, the question here, what it says is compare the velocity versus time graph with a position versus time graph. So this is the position versus time graph from the front of the paper. The velocity versus time graph has 3 mistakes. So that's what it says right here. It says 3 sections that do not represent what the lady was moving in the position versus time graph. So the problem here is we need to figure out what those 3 positions are, those 3 time intervals where the velocity versus time does not match the position versus time graph. Okay, so let's start at the beginning. You see the beginning here, this had a slope. Well, if you look at the front, it had a slope of 3 meters per second. So the whole time it was moving at 3 meters per second. So go back to the back, we look at the velocity. Notice from 0 to 2 seconds, it says 0, but then from 2 to 4 seconds, it says 3 meters per second. So that part is correct, but this part right here, that is not correct because it should be at 3 meters per second for that whole first 4 seconds. The second portion, if we go from 4 to 10 seconds, look over at the front again. From 4 to 10 seconds, we were moving at negative 2 meters per second. Negative 2 meters per second. So go back to the back. We have what looks like positive 2 meters per second. So because this says positive, but it should be negative, then this portion right here is also incorrect because it's above, meaning positive, but it should be negative 2 meters per second. The next portion right here from 10 to 13 is 0, so we go back to the front. From 10 to 13 is 0, so that matches, good. From 13 to 16 seconds, it says that it's going to be at 5 meters per second. So at 13 to 16 seconds, it's at 5, so that matches. And then right here at the end, from 16 to 20 seconds, it says it's at negative 1. So looking at the front, from 16 to 20 seconds, it says it's at positive 1 because it has a positive slope. So you see that positive slope right there should have a positive velocity, but you can see here we have a negative velocity. So that is another mistake because that should be positive 1 meter per second. So there are 3 mistakes. This one where it says 0 should be at 3 meters per second, so it should be there. This at negative 2 should be at negative 2, but it's at positive 2, so it should actually come all the way down and then over. And then the last section here that says positive 1, this says negative 2, but it should be at positive 1, so it should be up here rather than below.